Communications Lesson 2. I'll just share my screen with you guys. We'll do a brief recap of our first lecture. And look, I'm presuming that you got these slides from the college. So it was just a quick overview of computing in the workplace and the kind of the progression from the first workplace computers. They were great, big, expensive things, and only really big businesses could afford them. That sort of gave rise then to the personal computing, and you had these, the Xerox Alto. They were the first people to come up with what you call a graphical user interface. So this was how it looked. So this kind of thing. So this is a very early version of the interface that we're used to seeing now. Because up until then, people used to interact with computers through a command line interface, which is this kind of a thing, where you type in the command and you need to know all the commands. So quite challenging for non-technical users. So that changed over time, and you didn't need to type in what you wanted to do. And I suppose it was Apple, Steve Jobs, who revolutionized that. And then other operating systems. And remember, Microsoft started off as a software company first. And then how did computers change work? They allowed businesses to work faster. There was more data storage. You could talk to people. We could communicate like we're doing right now in terms of Zoom calls and that type of thing. People could work from anywhere. And eventually it spilled into computers for personal use. You had the Apple II, and all this progress, it's dictated by this chart that we looked at. Can anyone remember what this law of computing was called? A gold star for the one who does. So what's that law in computing where everything doubles in terms of power every 2 years? It's called Moore's law, and it's this type of thing. We looked at that, and down here, these are the first chips. Over here is where we are now, and these are the amount of transistors that we're getting into a chip. But look, we are getting to a point as well where we're hitting capacity, and there's only so much miniaturization that you can do. But that law has stayed fast for many years. And then technology today, and we're going to be looking at more technology, current solutions. So we mentioned this was like a robotic surgeon. This is telehealth, where a patient logs into a call with a doctor. Self-driving cars, the development of mobile devices, where you have this from a two-way wireless radio to the first smartphone, then to the advent of iPhones and these kind of modern smartphones we had. And then we also looked at digital imaging, and this was the first digital image and all the things that that has given rise to as well. And then I think the last thing we looked at was just, we mentioned gaming and just the evolution of games right up to contemporary technologies like virtual reality. So that's a quick overview of what we did the last day. So any questions on any of that, guys? So any questions or observations, or please free to pop them into the chat if you have them. I've lost my chat window. So all good. So I'll put those slides away. So today, let's start off, we'll talk about hardware and software and the differences. Let me just organize my camera again. So hardware and software. So the two components of any IT system, hardware and software. So the hardware, it's the physical components. It's the CPU, the hard disk, the monitor, the keyboard, the mouse. all those type of things. So the software, it's the programs or the applications. So if you think of your operating system, it could be Windows, it could be Mac, those things, but it could also be the applications then that run in those. It could be Microsoft Word, Microsoft Excel, all that kind of stuff. And the computer system, it requires both hardware and software to function. And then apart from those internal components that a computer needs, you've got additional hardware components that allow the user to communicate through inputs and outputs. So if you categorize the devices, so right now my keyboard and my mouse are an input. My camera is an input because it's gathering a signal from me and it's sending it to you. All those signals go into the computer and the computer processes them, and then you receive output. So output is the display, it's the printer, it's the sounds you hear. So that's the stuff you receive from the computer. So literally all those things it's computer hardware. So some questions. So what is a set of computer speakers, input or output? So you can type your answers in the chat. Output, because it pushes a sound out to the user. And a camera, my webcam, what is it? Is it input or output? Input. So anything that sends a signal, a control signal to the computer is input. Anything that pushes something out is output. What is a printer? A computer printer, input or output? Very good. What is a scanner? So a scanner, input, because we send a document from the scanner into the computer, we can do things with it, and then we print it, and then we turn it into output. So think of all the devices as what. So is it input or is it output? So all these devices, and inside the computer, that's where the software magic happens, and that's where you have your applications that allow you to manipulate and to process the information. So let me just go on to the next slide. So it's just a quick overview, and you can follow the link in your own time, but I'll just run it for a minute or so. Just let me know if the sound is
You may already know that there are many important parts inside a computer, but what exactly do they do?
Now, is the sound working? Can you hear the audio?
Let's take a look inside and learn about the various components that make a computer work. Whether it's a desktop computer or a laptop, every computer has a large circuit board called a motherboard. This contains some of the most important parts of the computer, such as the CPU, also known as the central processing unit or processor. The CPU can be considered the brain of the computer because it processes information and carries out commands. Since it tends to get hot, it's covered by a piece of metal called a heatsink, which draws heat away from the processor. The motherboard also contains the computer's RAM, or random access memory. This is the short-term memory that the computer uses whenever it's performing calculations. However, you cannot store your files there, because the RAM is cleared when you shut off the computer. The hard drive provides long-term storage, keeping all of the computer's data even when it's turned off. Many hard drives use a magnetic platter to store data, but many newer computers have solid-state drives, which are faster and more durable, but also more expensive. On many desktop computers, the motherboard has expansion slots that allow you to upgrade by adding expansion cards. You can add a video card to get better graphics performance, or you can add a wireless card to connect to your wireless home network. Most laptops, however, don't have expansion slots. Of course, the computer's components need electricity to run. The power...
Yeah, I might just pause it there, guys, because it goes on for another couple of minutes. It gives a nice graphic overview of all the different components in a computer. And I suppose the reason we're looking at this is because I want you to start viewing this development of technology as a journey over time. Because remember, we're all tracking Moore's law. So all the time, the capabilities are increasing. So if we look at the different types of processor, this was the first one that came out very early from Intel. And over time, then these processors have been upgraded. So down here, these are the new Intel Core Ultra processors. So the amount of calculations that these processors can do you've gone from millions to billions to trillions of times the capability of these original chips. So all the time you have ever increasing processing speeds and RAM capability. So RAM is the memory, or it's the amount of information that the computer can store. And then you've also got faster storage. So in the video, it mentioned solid state drives. So they're much quicker than more traditional hard drives in terms of grabbing information from the computer and then writing information back to the drive itself. So faster processors are needed for high definition tasks. So a good example there would be graphics and video editing. You also need them to have multiple applications open at once. And then, of course, high-speed internet is required for online activities such as gaming and cloud computing. So we'll look at both of those again. The computing demands place businesses and organizations in a never-ending upgrade cycle. So one of the things that we mentioned the last day was the advent of IT and computers. It actually meant that new departments needed to be created in business, because all of a sudden you needed an IT department. You needed people who understood how the computers worked, and they had to be able to fix them, maintain them, upgrade them. And then you needed people who were familiar with the software and they knew how to work it. So the ICT department, they carry out the maintenance and replacements of the computers. And then the IT networks and infrastructure, they require upgrades as well. So that's how all the computers talk to each other and connect. And then online connectivity, the last point here, it's the ability of individuals and organizations to connect to the internet using computers and mobile devices. And we take that for granted these days, but it wasn't always so. So like World WWW, I know it's coming up on I think it's its 40-year anniversary. It is a relatively new thing for mankind. And we have ISPs, and they're internet service providers, and they deliver connectivity to their customers, whether it's business, whether it's home users. And then based on the subscription you have, so you can have different packages with your ISP. So the more you pay, the greater the transfer rates that you will have with them in terms of your upload speed and your download speed. In parallel to those increases in hardware and connectivity, you've also had the increasing sophistication of software. So because the capacity to run the software, it's increasing all the time, and people are aware of that and they want to do new things. So they're making more demands from what it is the computer can do. But with that increase, then there's also this need for ongoing training. And one of the things we mentioned the last day was you guys are relatively new in terms of your IT careers. But one of the things that I have found is that I constantly need to stay updated and I need to do new courses and keep myself informed in terms of technology. Things like AI, they're relatively new technologies for the public, and it's something we'll see an awful lot over the next coming years. But I'm old enough to remember when cloud computing arrived, and one of the things I did at the time about 15 years ago was I went and I studied cloud computing, and I needed to understand it and how it worked, because before that it was all on premises, all the storage, all the servers, they were all in the same location as the business. Cloud computing came along, it was something new, and AI is something similar. So one of the things I did last year was I went and I studied an AI course to understand how this new technology works, and I'm hoping that I'll be able to use that study over the coming years. So with this constant change in technology, if you work in IT, you need training on a regular basis. In terms of software in general, the more advanced the software, the higher the purchase price. And we don't see the software or the hardware stopping in terms of their sophistication really at any stage. And in the future, it's likely that computers, which we know are a mix of hardware and software, will take over some of the tasks that humans currently do. And for example, AI agents. This is a really big thing now. Have you guys heard of AI agents? What does an AI agent do? An AI agent is essentially it's a piece of software or it's a computer program that I can ask to do a task. I can give it a job. So I go and book a flight, right, for me, and it will know to go to, it will know a couple of things about me. It will go and check my diary. It'll check my calendar. It'll go and identify the dates that are available in my calendar where I don't have any work or any meetings. Then with those dates, it will go to a flight website. It will book the flights. It will rank the flights in terms of order, and it'll come back to me. And so I give it a simple instruction. I say something like, I would like to go away next month. Where should I go? And it will go and it'll do all the internet search for me and come back with recommendations. And I could also have given it my card details so it could go and pay for the flight. Those technologies are getting to that stage now. What you also see less advanced are chatbots on websites, chatbot agents, where you contact a business and it goes, hi, how can I help you? And then you tell it, and they have them on Amazon and stuff like that now. I was using one last week. So these are all examples where tasks that humans traditionally have done, they're being taken over by software. So just moving on then, not only have computers got faster and software more sophisticated, they've also become mobile because we don't need a laptop anymore. We don't need a desktop. We can move around on our phones. So mobile computing, it's a technology and it allows transmission of data, voice and video. It's a wireless device, so it doesn't have a physical link. And in recent years, or in the last decade and a bit, we've seen a real rise in smartphone usage and a whole creation of an ecosystem for apps and for social networking. All that has been enabled by mobile computing. And then you have different versions of different types of software, because I can have Office 365 stored on my files on my desktop or on my laptop, but I can also edit those files on the go, say I'm on the train or whatever. So now what you have is you have the same file, but you can grab the file and work with it in multiple places. So that enables huge productivity. Like I was going to a conference yesterday and I was on the train and everyone on the train was working. So we're all just clicking away like we're very much at home or in the office. But one of the concessions then with mobile computing is that these smaller screens, it means the apps have to be redesigned because it's a very different user experience on this smaller screen where you're not using a computer or a keyboard and a mouse. So very different, but it means the apps have to be designed carefully. So cloud computing, and we'll have a little look at what cloud computing is in a little bit more detail now. It's the delivery of computing services. Is it storage? Is it software? Is it analytics? Is it AI? So it's that delivery over the internet. So the cloud, and that offers faster innovation and flexible resources and what they call economies of scale. Because until cloud computing, businesses, you needed to have basically all these servers and hard disks in your building, and you needed to employ somebody that would manage them all, and that was usually the IT manager's job. But with cloud computing, you're actually outsourcing all that work, and really with cloud computing, the only thing the IT manager has to worry about is the internet working. Can my devices in my building connect to the internet? Because if they can, the people in Google and Amazon and the cloud providers, Azure, they're the ones that are worrying about the file storage and is the database working and is it on? And with cloud computing, you have distributed storage. So there isn't just one copy of the file. It's dotted around multiple copies all over the region or all over the world, even in some cases. And with cloud computing, you typically pay only for the services you use. And this helps you to keep your operating costs for your business low. And then if you need more storage, you just upgrade your subscription in terms of storage. So you don't need to go out and buy new hardware. So this gives a business a ton of different options. So another quick little video, we'll just stick it on for a sec and then we can see if we have any questions.
Cloud computing is the on-demand delivery of IT resources via the internet with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider like Amazon Web Services. Organizations of every type, size, and industry are using the cloud for a wide variety of use cases, such as data backup, disaster recovery, email, virtual desktops, software development and testing, big data analytics, and customer-facing web applications. For example, healthcare companies are using the cloud to develop more personalized treatments for patients. Financial services companies are using the cloud to power real-time fraud detection and prevention. And video game makers are using the cloud to deliver online games to millions of players around the world. With cloud computing, your business can become more agile, reduce costs, instantly scale, and deploy globally in minutes. Cloud computing gives you instant access to a broad range of technologies so you can innovate faster and build nearly anything you can imagine. From infrastructure services such as compute, storage, and databases, to Internet of Things, machine learning, data analytics, and much more.
I'll stop it there. The rest of the video goes on for a couple of minutes, but look, the link will be in the slides and please go through it in your own time. So benefits, the top benefits of cloud and why has it become so prevalent and popular today? So cost. Cloud computing eliminates the capital expense of buying the hardware and software and setting it up and running it on yourself. So you don't need the racks of servers, you don't need electricity on all day for the power and the cooling, and you don't need the IT department or experts for managing the infrastructure. So huge cost savings. In terms of reliability, cloud computing, it makes data backup, recovery, and business continuity far less expensive because the data can be mirrored across multiple locations. And the cloud provider handles this for you automatically. And in terms of performance, the biggest or the larger cloud computing services, they run on a worldwide network of secure data centers, which are regularly upgraded to the latest generation of computing hardware. Let's just have a quick search. These are the AWS. So you can see it's worldwide. So that's for Amazon. This is for Microsoft Cloud, Azure. So this is Google, all dotted around all over the world. What does it look like inside? So this is inside Amazon. So these are the people who are doing the jobs that the IT department would not traditionally have done. So here's inside Google. And remember, this is just one part of the data center. But these data centers are huge, and then there's dozens of them all around the world, and then all the different providers have them. So this inside the world's largest data center, 2020. This is what they look like from the air. So these are big buildings. It's not even a building, it's a campus. These are huge, huge facilities. And then there's loads of them. And because these companies are so profitable and so big, they can offer their cloud services at a very low price for the consumer. Like I have a couple of subscriptions. I have some with Microsoft, I have some with Google. They're not very expensive, 10, 15, 20 bucks a month, this type of thing. But the capability that gives me is huge. Different types of cloud computing. You have public clouds. This is probably the most common. And they're owned and operated by third-party providers. And those providers, they deliver their resources. You're talking about storage, all that kind of thing. Azure, AWS, Google, they're all examples of public cloud. And everything is managed by the cloud provider on your behalf, and you access the services and you engage with them mainly through your web browser. You want to check your Gmail, you want to check your Microsoft account, whatever. Now, a private cloud is a little bit different. And this refers to cloud computing resources that are exclusive to a single business or organization. And a private cloud can be physically located on the company's on-site data center. And some companies also pay third-party services to host their private cloud. You see, I can go in and I can actually subscribe. It's like a more private version of the public offering that AWS would answer or offer. Why would a business need a private cloud? Could anyone tell me? So what advantages would a private cloud have? Why? And I think the clue there is in the name. So why would a business go with a private cloud? Security, faster, all those things. Generally, it's related to security. Like say, you think something like a government, right? A government will probably have their own data center or a bank or something like that. And if they don't have a data center, they will have a private cloud with one of the bigger providers because they don't want their information on the public cloud because there might be just a little bit more risk, right? Now, you can have the next point, which is what they call a hybrid cloud. And that's a mixture of public and private clouds. Think of the information that a bank would hold or a government. Some of it is more sensitive than others. Some of it is out in the public domain and you can find it on Google. And if somebody wanted to look me up, they could probably type in my name and see things about me. So that information is not really super private. But in terms of how much money is in my bank account, who I pay, why I pay them, all that type of stuff, that's more private. So the bank would probably operate a hybrid cloud where it would hold some of the information in more publicly and then some of it more privately. And you get the best of both worlds with a hybrid cloud because it allows the data and the applications to move between the two different cloud types. And also the cloud gives you the business more flexibility, more deployment options, and it helps optimize your sort of security and your compliance. So really there are the three main types. There are some others. You've got public, private, and hybrid. And then also in cloud, you have different types of services. So you have infrastructure as a service. And this is the most basic category of cloud computing. And with infrastructure as a service, you rent IT infrastructure, servers, virtual machines, storage, all that kind of stuff. So it allows you to run your business applications on somebody else's hardware. So it's almost if you need processing power, you need somewhere to store things, you can either have that in your building or else you can use somebody else's hardware to do it. You've also got what they call platform as a service. And that refers to cloud computing services that supply an on-demand environment for developing, delivering, managing software applications. So if you're building out software and you want to send your software to your users, you would use a platform as a service. And PaaS is designed to make it easier for developers to create web and mobile apps. And it frees you up from having to worry about setting up or managing servers, storage, databases, because you need all those things when you're building an application. So again, all the cloud providers would offer these as services. Another service is software as a service. And this is the one you're probably most familiar with. So software as a service, it's a method for delivering software applications over the internet and on demand, typically with a subscription basis. So you're, in a way, something like Netflix is a software as a service, because you pay a monthly demand fee and then you get content, or even my Gmail account. These are all software as a service. So I pay a monthly fee to Gmail, and then I get access to Docs, I get access to Sheets, I get access to Gmail, all these other things. And I get that for about €10 a month. So that would be an example of a software as a service. In this case, it's like an email provider. And with SaaS, cloud providers host and manage the software application. They handle upgrades, they handle maintenance, they handle fixes and security, and the users just connect to the application over the internet. And it's generally via a web browser or some kind of an app. But that is everything, all the responsibility has been pushed over to the provider. So whatever that software is, you have different types of, think of all the different types of software subscriptions you can have. You don't worry about anything. You don't need to host it. You don't need to maintain it. You don't need to keep it secure. So the provider does all that, and we just pay them a licensing fee or a subscription fee, $10, $15 a month, whatever that is. Just moving on. So just before we move, any questions about cloud? You're all pretty familiar with cloud, are you? So what email service do you use? Did you use Gmail?
Gmail.
It's really good. And even the free service is great. It gives you storage. It gives you access to all the apps, which is almost like the Office suite as well. But there are lots of other providers as well. And they basically, even a lot of colleges use Gmail as their sort of communication system. And a really good way as well for businesses to share information, because you can build a doc and then you can share it with different people. You don't need to attach it as an email and all that sort of stuff. So you've all probably grown up with cloud computing just running in the background for you. So the next thing I want to look at is, yes, big data, right? And we touched on this briefly the last day. And we mentioned just the rate of collection of data, or the amount of data that we all generate. If you think of something like the social media companies and all the interactions and all the clicks and all the likes and all the content that the users are posting, it's a huge amount of information. And in the background, you have Meta and you have these big technology companies, and they're just collecting all that data. And it's being created by millions, billions of clicks per day. And I saw a kind of a metric yesterday as to what ChatGPT, in terms of the data that was being input into it, it was absolutely huge. And all that information is being collected, and it's being analyzed, and it's being understood, because those services, that they want data. That's how they keep going. That's how their advertising kind of business works. So like all the things we've looked at to this point, all the advancements have resulted in data being just produced at astronomical rates. And like big data, and if you think of a business collecting all the information across the business, like it's so valuable to the business, because when you have good data, you can make better decisions, because you can see what's happening in the business. But that means that the business has to be able to collect, store, analyze, and respond to the data. So a lot of the time, it can be hard to see what's going on. So you need to do things to help you. So then you're talking about visualizations, dashboards, graphs, things that are easy to discuss at meetings and for people to understand. So a lot of software applications, they will have the transactions, all the things that are happening will run in the background. And then the part that you actually look at is like a dashboard where you can see stuff. Is it going up? Is it going down? How are our sales for last month, last year? How does last year compare with this year? This type of stuff. So it's easy for us to understand and to spot patterns. And all this helps the businesses to understand things better and to make better and more informed decisions. So there's just another little quick video, a couple of more links. I'll just run it for a sec.
To many people, this is what big data looks like. Streams of abstract information. All kinds of data gathered from internal and external sources like CRM systems, customer contact, billing, market research, social media, mobile data, and more. Together, this data must surely be able to deliver value for both the company and the customer through a deeper understanding of customer behavior, brand performance, and market development. At least, this is what big data promises. But in the real world, it's not that simple. How do you go from accumulating the growing amount of abstract and diverse data to gaining insights for making substantial impact? In creating value with big data analytics.
Yeah, I'll just pause it there. And it goes through that. So check out the links, please, in your own time. I'm just going to keep moving forward because we've got about 10 minutes left. But big data and analytics, again, enabled by all the developments we've seen in technology over the years. And check out the links, please. And then IoT, Internet of Things. So this is another technology, and it allows devices to be smart, even devices in your home, your heating system, your fridge, your water heater. And the IoT presents opportunities for businesses. And an example there would be farmers who can use sensors to monitor rainfall and to trigger watering systems when it's been dry. And challenges would include safety and the need of online security when data is being stored and transmitted. So if you think of IoT as sensors, and they feed back to the main computer network. So remember our diagram at the start, we had input, processing, and output. So these would be providing input in the same way that a keyboard, a mouse, some sort of a thing that transmits to the computer does. So IoT is huge, and now you have these concepts of what does a smart home look like? So what does it look like? So a smart home, and it has all these different options. You have lighting, you have heating, you have all these things, and it's all controlled from a smartphone, or you have some kind of a smart speaker and you can say, hey Alexa, this type of thing. This is all enabled by IoT. There is another short video. You can go and have a look at that in your own time, and it'll give you a little bit more detail on how it works. But in general, IoT is a broad term used to describe the devices, sensors, and everyday items. They're not generally considered to be computing, but they have internet connectivity, and they pass a signal back to some sort of a computer system or network. And you have these devices, IoT devices, in cars, trucks, and consumer goods, all different things. It's given rise to this concept of smart cities, smart homes. And these devices or objects collect data from their surroundings, and then it's transmitted and analyzed, and that creates just a ton of new opportunities for businesses. The scale of these is just astronomical, 100 billion by 2025. But some of the challenges then that are associated with IoT, security, like I saw a video recently where guys actually hacked into a car. So it was driving along the highway, and they were able to break into the car because the car was connected. I think it was might have been something like a Tesla or something like that. And they were able to stop the car in the middle of the highway just without the driver's consent. So the driver was driving along, the guys, they had some code, they passed it across to the car, and the car just stopped. So security, a real issue with IoT. And Then you have this interoperability in standards. How do all these different devices talk to each other and ping back to home base, and how will all that work? Privacy, again, using the example of the car. I have a new car, a smart car, and it knows everywhere that I'm going. And that can be scary. Do I really want the car manufacturers knowing everything I'm doing? So again, a real challenge for IoT is privacy. You also have regulatory, legal, and rights issues that are associated with it. And then you have issues for emerging economies and developmental issues. Because for the benefits of IoT to be realized and to be global, you don't want a mismatch between different areas of the world. So IoT, again, a huge thing in current technologies. We also have increased automation and we have robotics in factories. And this is expanding all the time. Industrial robots now carry out a lot of repetitive tasks in manufacturing. Now, these robots, they're expensive. They need to be programmed. They're not adaptive, or they're not suited to varied tasks. So you can't ask a robot to do something new in the same way you can tell a person and they will figure it out. So again, just a quick...
Robots and factory automation solutions have been facilitating industrial production for over 60 years. FANUC is present in 120 countries, including Hungary, assisting key sectors like the automotive industry, for example, at the Audi Hungary Motor Limited factory in Győr, where they are developing and manufacturing cars for the Audi AG and the Volkswagen Group. Audi Hungary is one of the companies with the largest turnover and export in Hungary, producing 2 million engines and 135,000 cars in 2014.
In our experience, FANUC robots work reliably at our factory. We are constantly...
No, let me just pause it there. Go in and check that out, because it's quite amazing the level of automation and robotics in the factories. And this is happening today. It has been happening for a while. So again, a future technology that's sort of here today. For all these, you have advantages. You also have disadvantages. So I'll fly through these quickly. You have safety issues in terms of the advantages: productivity, capability, quality, affordability. The disadvantages: very expensive to set up, hard to train, maladaptive. So robots cannot do different tasks. They also can lead to worker displacement, because you'll notice in the video there weren't that many people there, and also the repairs. So pros and cons to these sort of industrial robots. Exoskeletons, another sort of future technology that's here today, just allows the worker to do more things and to work for longer. Again, another quick...
This is the ExoWorks industrial exoskeleton. And the point of it is to let somebody who looks like me take something that looks like this, which is a Milwaukee grinder, and hold it over their head for a long time as though it didn't weigh anything. Exobionics grew out of a defense-funded project to make a load-carrying suit for military applications. But the company's best known for a spin-off, a powered therapeutic exoskeleton that people who are paralyzed or suffered strokes can use. Now the company is going back to its roots in a way, with an exoskeleton built to make difficult human jobs a lot easier. Exo isn't the only company getting into exosuits, but they are one of the first to build one aimed more at construction workers and special forces.
Put a large metal bit in the...
Sure.
And then work it, actually.
And now we
More
see
than 5 minutes.
Now we see why I went into journalism.
That's right.
That's crazy. I got to try out the suit at Exo's Richmond, California factory. It's adjustable for people from 5'4" to 6'4". It weighs about 16 pounds, and it feels a bit odd at first. If you could not twerk in this, it just wouldn't. I wouldn't recommend it, let's say. The Exo industrial suit's made for heavy industry and construction. It's less Tony Stark's Iron Man armor and more the power loader from Aliens.
Back then, they had the idea of exoskeletons for industrial applications. And the interesting thing about that is Aliens was scheduled in the year 2020. So in our minds, we got 5 years to get to that.
But the exosuit is still pretty far from Ripley's Alien Slayer. This thing is actually completely analog.
But our industrial exoskeletons, our first round of products, are actually passive. So there's no electronics, there's no batteries, so there's nothing to be plugged in, which makes it pretty exciting.
But then how do they fly and shoot laser beams from the car?
There's no laser beams. We don't have the arc reactor yet, like Tony Stark.
Right, so let me just pause it there. So exoskeletons, and the guy mentioned right now, they're analog. So it's supports and wheels and cogs, but there are digital exoskeletons as well, where they're actually powered more by motors, and it gives, you see them in military kind of applications as well. Again, we're just going through all these different sort of technologies that are part of this computing and technology journey. The last one we'll look at is wearable tech. We touched on this briefly the last day with the virtual reality. But right now, wearable tech is one of the fastest advancing sectors, and its development is outpacing the development of smartphones. It's like a secondary market that has grown up, because at this stage, most people have some form of a smartphone, and now they're saying, what else can we sell the consumer? Can we sell them a watch? Can we sell them a headset? Can we sell them some sort of glasses or goggles? And these wearables, they use sensors to connect to the person, and then they can help you achieve different goals. Stay fit, lose weight, and in the case of VR and AR headsets, it's like a new way to interact with a kind of a physical world. You have this augmented reality. Let me just, Apple VR, we looked at these things, Vision Pro, and I think Meta had one as well. And they're these goggles or glasses that you put on, and then it gives you this layer of digital in the real world where you can see stuff and you can just interact. So think of something like this, walking around a new city with maps in front of you, and it's giving you reviews and all this kind of stuff. So then look, that is the last slide I wanted to share for today. But look, please just treat this as like a journey and go in. Let me just stop sharing. Okay, we should be back on full screen. Now, let me just open up.
Thank you, sir.
Okay, so yeah, look, I'll share the slide. Go in and click through some of the links, some of the videos, and there's some kind of interesting stuff there. But look, all this is a journey, and we started way back with the very basic computing hardware, and we've come sort of 50 years into the future, and you can see where the technology has brought us. And look, where are we going to be in 50 years? It's super exciting. I'll catch up with you next week, and looking forward to chatting to you all. Thank you for joining me this morning. Okay, take care. Bye-bye.